One of the things you can also do before you notice it is say to yourself, well, I know that 32 is 2 to the 5, and you rewrite 32 as 2 to the power 5. And now if you have an equation where you have 2 to the x equals 2 to the 5, does it make sense that the only way that that's possible is if x is equal to 5? So what we're going to be doing is looking at some that are a little bit more complicated. What happens if I said 3 to the 2x equals 27? What's x? Well, 27 is in our powers chart as a power of 3. I could rewrite 27 as 3 to the 3. If this side is 3 to the 2x and this side is 3 to the 3, if we have the bases the same, does it make sense that the exponents would have to be the same? And so 2x would have to equal 3, and now we're back to a grade 9 solving for x equation. How could I get x by itself? Divide both sides by 2, and you get x is equal to 1.5. So what we're going to do for the next couple of questions is we're going to think about our powers chart, and we're going to use the strategy that if we can get the bases the same on both sides of an equation, then the exponents would have to be the same too if they're equal to each other. And with that idea, we can solve a number of questions as long as they fit within the powers chart. And then later on in this unit, we're going to look, what can we do when it doesn't fit in the powers chart? How do we do that? So going to example 1. For part A, we're going to use our powers chart and our exponent laws to write both sides of the equation with the same base. That's our main strategy. Because if we can get the bases the same, then the exponents have to be the same. So in part A, we look at our numbers. On the left-hand side, we've got the number 4. On the right-hand side, we've got the number 256. Are 4 and 256 in the same column of our powers chart? Yes. They happen to be in the same column in 2 different places. Can you see that it is 256 is 4 to the 4? So I would probably start off by changing 256 to 4 to the 4. That's using my powers chart to get them to have a similar base. The difference right now is on the left side I have a base of 4. On the right side, my base of 4 is in the denominator. So now we have to use our exponent laws. How could I rewrite this as 4 to the power of something? You would have to use your negative exponent rule and say it would have to be 4 to the negative 4. Once you've got both sides of the equation with the same base, well, the bases are the same. And what I like to do just for writing things out for this next part is go, so, because it's not really, the next step isn't really mathematical. It's just logic. If 4 to the x equals 4 to the negative 4, then I know that x is equal to negative 4. That's just using logic. If both sides of the equation are the same, if the bases are the same, then the exponents would have to be the same. And so we can solve for x that way. Part B is a little bit more complicated. All right. We start off with 27 to the x. Nine to the 2x minus 1. So step 1, we want to write both sides of the equation with the same base. Do 27 and 9 ever appear in the same column? Yes. They're in the powers of 3. So I could rewrite 27 as 3 cubed, but I would still have an x here on the left-hand side. Does that make sense? And then on the right side, I could replace 9 with 3 squared, but I would still have 2x minus 1 there. What's your exponent law for a power to a power? You multiply. So this side becomes 3 to the 3x. This side becomes 3 to the 4x minus 2. So again, we need to know our exponent laws well, because now I've written both sides of the equation with the same base. So this is the part where I use logic and say, so I know that 3x has to equal 4x minus 2. Rearranging, bring my 3x over, give me x, moving my 2 over. X has to be equal to 2. So our job is to see how we can use our algebra skills and our powers chart and our exponent laws to get both sides of the equation with one single power where the bases are the same. If you can do that, then the exponents have to be the same, and you can solve it from there. So we got some questions to practice.